Hi, this is Irv Shapiro with the MakeWithTech channel. And today we're going to cover a rather technical topic. We're going to cover the topic of what file formats you can use with a 3D printer. Now, if you're like a lot of people, you look for models online, you download STL files, you use a slicer to convert the three-dimensional STL files into a series of layers that are in the G-code format. You print them on your 3D printer. You may or may not actually know what an STL file really looks like inside or what G-code really looks like, but it doesn't matter. You get the job done. So today we're going to take you inside. We're going to talk about those file formats and define them in detail. But in addition, we're going to talk about a range of other file formats that you can use to create exciting and interesting things with your 3D printer. So stay tuned and let's learn something together. Now, before we get into the bits and bytes of 3D printing, I want to remind everyone that MakeWithTech is now a whole community of folks that are interested in using desktop technology to make things. Very often, very interesting things that may even combine different types of objects. It might combine 3D printing, a little woodworking, a little electronics, other things. And at MakeWithTech, we now have a series of places you can go to learn about this stuff. You can go to the YouTube channel, and I always appreciate it if you subscribe, give me a thumbs up, share these videos with other people. You can also go to forum.makewithtech.com to share ideas, post pictures, get help from thousands of viewers of mine that are interested in discussing these things with each other. And now you can go to models.makewithtech.com. That's where you'll find this model as an example. And you can download models that are customizable for just what you need. Now, let's talk about file formats. We're going to divide this video into two parts. The first part is actually going to define what a file format is and how things are saved in a file format. Now, if you're already a bit of a computer expert, maybe you're a programmer, maybe you're an engineer, maybe you're a graphic artist, you may know all this stuff. And you may want to skip to the second half of the video, or you may want to watch it just for the review. In the second half of the video, we're going to show you hands-on how to take different file formats and prepare them so you can create things on your 3D printer. Graphic file formats are really divided in a couple different ways. First, you have graphic file formats that are drawings. Those are one-dimensional representations of something. A plan of a house would be a drawing. Then you have file formats that are able to represent three-dimensional objects. Furthermore, you have file formats that are proprietary. They're for one particular company's program, maybe Adobe Photoshop PSD file format. And you have file formats that are open. They're available to everyone. They're not unique to a program, and they're often used to exchange things between programs. So JPEG or SVG or STEP, some file formats we'll talk about, and even STL that are sort of generic and open to everyone. But then at a different layer of understanding, file formats for graphics are divided by files that represent things with dots versus files that represent things with shapes, technically called vectors. So let's look at this picture. On the left-hand side, you'll see a rectangle represented with dots. So you have red dots and white dots representing that rectangle. Bitmaps or dots are the way we represent pretty much all photographs, JPEG images, GIFs, BMPs, PNGs. These are all extensions, types of files, but they're just different ways for representing dots. Those are called bitmaps. On the right-hand side, you'll see something that's a vector. In a vector, you're representing a drawing of some type with shapes, squares, circles, lines, points, which are in essence dots, but points, text. And these vector formats are very precise and tend to be smaller than bitmap formats. But they don't represent everything as well. A photograph where you need a lot of dots and very fine color gradations are better represented as bitmaps than as vectors. A three-dimensional object that you want to recreate later is better represented as a vector. Now, how are these actually saved to that disk in your computer, to that USB key, to that SD card? Let's look at the next slide. You'll notice for the bitmaps, you don't have a number representing color for every single dot. You could, but in order to take less space, you may have a number that's a repeat count and then a number that represents a color. On the other hand, vectors are saved in a different way. You actually have a descriptive language that might say something like, start at this point and then draw a square, fill it in this color. So you'll see an example of that on the right. Now let's look at a real example of a vector format called an SVG, which is one of these open formats for exchanging vector-based graphics. And you'll see here highlighted in yellow is how you would put a rectangle on the canvas on your drawing. So you'd position to X 206, Y 208. You have a rectangle that has a width of 50 by 50 with a style of filled in with a code, a color code of 22977, whatever that color is. This is a vector format. Now, we don't really use bitmaps or vectors directly with our 3D printers very often. What we learn about are STL files. If you go to Thingiverse or you go to models.makewithtech.com or you export from Fusion 360, you're probably going to export an STL file. Now, how do STL files work? Well, look at this picture for a minute. If you look closely and we zoom in, you'll see there are a whole bunch of triangles. Now, quite a while ago, a really smart guy discovered that if you take triangles and you take enough of them and you put them on different angles, you could represent any shape by combining triangles together. Any shape. And the more triangles you have, the more details, the higher the resolution of the shape. And the STL file format is a file format that saves triangles. So instead of doing dots like a bitmap, you can in some ways think of an STL like a bitmap of a three-dimensional object, except instead of using individual dots, it uses triangles. Now there's a problem with that, and the problem is a 3D printer does not print triangles. A 3D printer basically is a pretty dumb device. One layer at a time, it makes a drawing by extruding filament. Then it moves up another layer and makes another drawing. Moves up another layer, makes another drawing. That's all 3D printer is. So if we look at this picture here, you'll see that it represents layers on the left. If we take a layer and we flip it up so we can see it on the right, this might be this polygon, and each color segment is an extruded piece of plastic. Now they're all, let's assume they're all in the same color. I put them in colors here just so you could see on the diagram. So we need a way to tell our 3D printer to extrude a piece of filament from this point to this point. That standardized language for telling most 3D printers, not all of them, most of them, specifically filament-based 3D printers, because some of the resin-based printers use a different methodology, is called gcode. And therefore, as many of you already know, the purpose of a slicer is take this three-dimensional object and slice it into layers and then represent each layer of G-code. Well, this is what G-code looks like. So if we look at this particular two commands here, the first command says go to home, go to the 0, 0 position. The second command says go to 10 over the same Y position, so Y0, at a speed of 300 millimeters per minute and extrude 0.04 millimeters of filament. So it's going to create one of these segments. And so each one of these changes of direction is a G-code command. That's all G-code is. And if we look at it in a slicer, we can see here that on the left-hand side, we can see what a single layer looks like. And you can imagine how the G-code would be written to create that layer. And by stacking those layers one on top of the other, you end up with a shape like the shape you see on the right-hand side. Now, we've talked about a couple file formats already. Bitmap formats, which are things like JPEGs or Photoshop format, vector formats, which are like SVGs, three-dimensional universal formats like STL. So let's divide these into categories. So the first category on the left are some examples of proprietary formats used by specific programs. PSD is Photoshop. AI is Illustrator. FCSTD is FreeCAD. F3D is Fusion 360. These are proprietary formats that can only generally, I'm oversimplifying here, but generally be opened by the program from the manufacturer that defined the format. Now in the middle column, we'll see sort of universal formats, formats that the industry, the community has embraced. The first three, BMP, GIF, and JPEG, are for bitmaps, individual dots. SVG, DFW are two formats for saving vectors. STEP, STL, Object, and 3FM are four formats for saving three-dimensional objects. So theoretically, you want to be able to go from any one of these formats to something you can 3D print. And I'm going to show you a couple examples that'll help you get there using some universal formats. Now, there are really two competing formats now. There are many formats. Number that I haven't even mentioned, like OBJ or others. But there are two real competing formats in the 3D printer world for a universal 3D representation, and they're both based on a variation of triangles. One's called 3MF and the other is called STL. Now, STL was developed back in 1987. It's a relatively old format and it produces files that work well, but they're a bit limited and they tend to be very big. So Microsoft a few years ago designed a new file format called 3MF. And then they provided it to the community, so it's now a community-based format where Microsoft helps with the definition, but it's community-based, and people like Prusa have heavily embraced it. It's available in Cura. It's available in a number of different products. So when you're ready to convert that three-dimensional object in some proprietary CAD program into triangles, you can save it as STL or 3MF. Let's look at the screen for a minute. So the advantages of 3MF are that you can save more than one object to a file, and a 3MF file can have more than one object in a file. You can save information about how to print it, what filament to use, the color filament, printer information. Now, unfortunately, that printer information is often saved in a non-standard way. There's not a good set of rules about how to save that exactly yet. You can save thumbnails in a more standardized way, so you can have little pictures on your printer screen. You actually save a unit of measure in the file. With STL files, there's no unit of measure. It's just a universal unit. Now, generally, slicers interpret that as millimeters, but it could, there's variability there. because it's not actually saved into the file. And the big advantage, we're going to show you this in a minute, of 3MF files is they're much, much smaller. What is the disadvantage of 3MF? It sounds perfect. Is the standard is not quite as locked in as STL, which has been around since the 1980s. So as an example, if I load an STL file into Cura as my slicer, it almost always comes up right in the center in the right place. If I load a 3MF file, it sort of depends who produced it, how it was produced, as to where it will show up in Cura, and I might have to move it around. Not a big deal, but a difference. So let's take a look right now at STL versus 3MF in a very quick example. I'm going to go to a site that I produce, that I provide to the community, called models.makewithtech.com. And models.makewithtech.com is designed to allow you to search Thingiverse for models in a particular format called the OpenSCAD format, and then customize them, change them. As an example, if we were to look at this model, which is used for this light fixture, it's actually one of my favorite models. You can change the number of shards, the height of the shards, how big the base is, not just scale it universally, which you can do in a slicer, but change specific things. So that's what models.makewithtech.com does. So I'm going to actually click on Search MakeWithTech because it can search Thingiverse or the MakeWithTech directory. I'm going to search the MakeWithTech directory. And I'm just going to pull up one of my favorite models, this one right here. I'm going to search for a crystal. And here we go, and you can see this model is pulled up on the screen. And this will let me customize it. To customize a model in models.makewithtech.com, you click on this little 3D icon down here. And you'll see here some information about how to use the model from the author. But you'll also see that you can actually customize all of these various factors, including the size of the base. So the base top could be, let's make it a beveled base top and see what happens. So I could click on preview, and it'll take a few seconds because it's actually doing a rough render. And then I could zoom in a little bit here. And we can change the base or the number of shards until we get it the way we want. Then we have to go from this OpenSCAD file format, and I'll show you what that looks like. OpenSCAD looks like a programming language where the author of a model takes and uses these programming commands to place specific shapes somewhere on the screen. So we're going to send this off to render. That means to take the programming language and convert the file for 3D printing. And then I'll show you another example of OpenSCAD. So I'm going to queue it for rendering. And you'll see here I have the output format set as STL. And we're going to look at the difference in a moment. So let me go back over here. Wow, that already finished. But let's go back over here and let's look at another model very quickly. Let's look at a cup. And we have a coffee cup model that I actually produced. And if you look at the code in this coffee cup, you'll see it has just cylinder commands that have sizes. Because if we look at this coffee cup as an example, it's really just 4 cylinders. There's a cylinder for the cup itself. There's a cylinder to cut out the inside. Think of it as a negative or an empty cylinder. There's a cylinder for the handle and a cylinder to cut out the handle. So if we look at this program to produce a coffee cup, you'll see there's 1, 2, 3, 4 cylinders here. And they're just combined in a particular way to make a cup. And the result of that is this coffee cup modifiable, because that's the beauty of the customizer here. So I can change the height of the mug, I can change the diameter of the mug, I can change the thickness of the mug, I can change where the handle is. Now, let's go back to our crystals. And this time, I'm going to change the output format to 3MF. Remember I said that it's also based on triangles, but it produces smaller files. So I'm going to queue it for rendering. I'm going to say OK. Now I can actually watch things that I'm waiting for, that the system is processing, and models.makewithtech.com can handle 1,000 simultaneous rendering of files. And this is all finished, and this is telling you some details about what it rendered. But now let's look at the output listing, and you'll see there's an STL file here, and that STL file highlight these 3 digits to make it easier to see. You can see it's over a megabyte. Yet the 3MF file is about 70,000 bytes. So that's one of the advantages of this. Now, if we download this file, I'm going to download the 3MF file because it'll download faster. You'll see another feature of models.makewithtech.com, and that is if you appreciate what the author has done, you have the ability to support the author by buying them a coffee, which is just a way of tipping them. So you could tip this particular author. In this case, I'm not going to tip the author. I've tipped Code and Make, the author, before, so I'm just going to dismiss this. So STL and 3MF, 2 file formats, which are outputs of computer-aided design programs suitable for use with a slicer, a program that we use for creating G-code. What if I have a bitmap? Now, a bitmap is a 2-dimensional object. What good would it be to 3D print that? Well, if I convert it into a 3-dimensional object in a very special way, it will be a 3-dimensional photo. So if I have a thickness of plastic and I shine a light through that thickness of plastic, the thicker it is, the less light will go through. So if I had a way to convert an image into different thicknesses and I put a light behind it, I could have, in essence, a 3D printed photo. Those are called lithophanes. Let's look at how we can do that. So I'm going to open up Cura. And you can see this is set up for my Flsun Super Racer. I love that printer because it's so blindingly fast. There are 2 printers I use pretty much all the time now, and that's an Ender 3 S1 Pro and the Flsun Super Racer. The Ender 3, if I weren't the ultimate of quality and flexibility in filaments because it goes to 300C, and the Flsun if I just want fast print. Okay, now I'm going to open up a file that's not an STL file. Normally, just to refresh everyone's memory, you open up STL files and they come into your slicer and then you slice them and you end up with individual layers that you can print on a 3D printer. And we can preview what this would look like, the individual layers, and we can rotate this around and look at the layers. But I'm going to look at something very different. And let me rotate this around and delete this. This time, I'm going to import, I'm going to bring in a flat file, 2-dimensional file. So let's go over here and let's open up this JPEG file. So you'll see here, it's going to give me an option to convert this image. So how high do I want it? So that's the maximum height that for the part that's going to be darkest. I'm going to leave that at 2.5. How much of a base do I want on the bottom? If I make the bottom base too thick, no light will shine through. But I'll leave that alone for right now. But I'm actually going to change this to 5 millimeters high to show I can show you a more extreme example. And then the size, and is darker higher or lighter higher? Do we want it to look like a negative or a positive? We're going to say darker is higher. And now I'm going to click OK. And what we can see here is Cura has created an image. This is a picture of me. But if we look at it from the side, let's look over here, we can see it has various heights. And when we shine a light behind it, those various heights will create an image. So now let's look at how this would actually look if we shined a light behind it. This is a lithophane that I made for my father's 90th birthday. You can see here in the center, these are images that are lithophanes. They were all printed on a 3D printer. Now, if you have something in a computer-aided design program, formats like the native format in Thingiverse that you never actually see, it's just in the screen, it's in the cloud somewhere, or FreeCAD or Fusion 360, or I showed you an example of OpenSCAD, how do you create an STL or 3MF file? So I'm going to open up FreeCAD. FreeCAD is a computer-aided design program, a program for producing 3D models. And I produced a 3D model that we can see here of a pawn. And it's beyond the scope of today's video to talk about that. There are a bunch of videos on the channel about how to use FreeCAD. It's completely free. That's one of the reasons I often teach people how to use it versus Fusion 360, which is a remarkable program, but it's free for hobbyists, but there are rules around it, and maybe it's not free. It's hard to figure out exactly what their licensing model is. So I just use FreeCAD. So I have this model in FreeCAD, and it's saved in a proprietary format, but I want to 3D print it. So I need to put it in a universal format. So how would I do that? Well, I select the object, see the blue lines around the object, then I do an export. And this is the trick for all of these programs. Tinkercad, FreeCAD, OpenSCAD is generally to produce a file for 3D printer, you do an export. I'm going to say export this. You can see I've already done this, but I'm going to export it, and you have a wide range of options. I'm going to choose STL, say save. It already exists, so I'm going to just overwrite it. So that's all you need to do. So the hint there is look for export in your 3D drawing program. One of the file formats that has lots of content are SVG files. Now, SVG files are vector files that are two-dimensional. They're flat. So as an example, if we just go to Google, we could look for an SVG file of a house. And it's going to come up with a whole bunch of examples here. And then you could save these SVG files to your disk. But how's that going to help you? Well, maybe you want to make a house cookie cutter. Well, this would be perfect. It's an outline. But I need to make it three-dimensional. So how do you make it three-dimensional? Or better yet, maybe you want to draw just a completely free-form drawing and turn it into a three-dimensional shape. How could you do that? So I'm going to talk about two programs today. One is called Boxy SVG, and the other is called Tinkercad. So I'm going to open up Boxy SVG now. And Boxy SVG is not free, but it's really very inexpensive. I don't know, maybe it's 10 bucks, 12 bucks, 15 bucks, something like that, or you can rent it. It's very inexpensive. And what I'm going to use it for today is it's a program for creating SVG files. Now, there are other completely free programs for creating SVG files. I just found them harder to use. I find Boxy SVG very easy. So I'm going to click on freehand over here, and I'm literally going to create a crazy shape. And then I want to turn this shape into a three-dimensional object. So what do I do? Well, this is two-dimensional. So I'm going to take and I'm going to save it. I'm going to save as, and I did this once before, so I'll just reuse that name, randomshape.svg. And one of the nice things about Boxy SVG is they produce SVG files that are very close to the industry standard. So they'll work in the widest number of environments. So if you have an SVG file and I'm going to show you how to use it with Tinkercad that doesn't work with Tinkercad, just open it in Boxy SVG and resave it, and that'll fix it. And now I'm going to go to Tinkercad. Now you'll see here, I've drawn lots of different things in Tinkercad. And the way most people use Tinkercad, we'll actually just show you an example here. I'll say create a new design. And then you could drag shapes into your screen. and you can combine those shapes together. And when you combine them together, you create new shapes. So the basics behind most computer-aided design are you take a bunch of shapes, you combine them together to create new shapes. Now, Tinkercad does not have an easy way to just do a random shape. They give you a bunch of standard shapes you can combine together, and it's very nice. But let's say I want something completely random, or I wanted that house, I want to make it into a cookie cutter. Well, then I do an import. And I'm going to choose a file, and the file I'm going to choose is this SVG file. And I'm going to say, go ahead and import it. And so that's bigger than I'd want. So let me make it a lot smaller, move it back over here. And you'll see it's automatically taken my two-dimensional object and made it 3 dimensions. And now in Tinkercad, I can change those dimensions. And let's say this was going to be something where I need to modify it. Well, I could take and drag a hole onto the screen. Let me move this over here so we can see it better. I can make it deeper. I can drag it over here. Then I can combine those two shapes together. And now I have my shape with a hole in it. Maybe I'm producing a piece of art. So SVG files can often be brought into a CAD program, Tinkercad or FreeCAD or Fusion 360 or other computer-aided design environments. OpenSCAD as a way to bring in SVG files. And then extruded, that's the language of CAD, to make them 3-dimensional. Well, folks, I hope you learned something today. I hope you found this interesting. Maybe you just learned one thing, like the fact you can use Cura to create lithophanes. Maybe you learned more. In either case, if you like this video, give me a thumbs up, subscribe to the channel, recommend it to your friends, go to forum.MakeWithTech.com, go to models.MakeWithTech.com. Embrace the community. Have a great day, and let's continue to learn things together.